In this lesson, we are going to begin with geometric sequences. We will state whether a sequence is geometric and then be able to write the explicit rule for our geometric sequence. Let's begin by defining a geometric sequence. It is a sequence where each term changes at a constant multiple or rate. Let's take a look at some examples. For the first example, we have 5, 10, 20, 40, 80. Notice that this time, instead of adding or subtracting to get to our next term, we are changing by a constant multiple, which means we are multiplying to get to the next. So if we take our first term of 5 and multiply it by 2, we get 10. Multiply it by 2, we get 20. Multiply it by 2, we get 40. Multiply it by 2, we get 80, and so on. In our next example, we want to see how we change. So from 12 to negative 6, we're simply going to divide by negative 2, or our constant multiple, which means instead of dividing by negative 2, we're actually going to multiply by negative 1/2 each time. That works then to change from division, but using the multiple, we just use a fraction, and then we're multiplying each time by negative 1/2. So we have negative 6. If I multiply that by negative 1/2, I get a positive 3. Multiplying by negative 1/2, I get a negative 1.5, and so forth. So over here on the right, we have some non-examples. 2, 4, 6, 8. We're just adding 2 each time. That is not a geometric sequence. That would be an arithmetic sequence. And then when we're talking about multiplying by different values, that would not be a geometric sequence. So what we want to do first is to be able to write the first 4 terms of the sequence. So I want term number 1. So if n is equal to 1, which is my first term, all I need to do is put it in this formula to find my first term. So I'm going to put n is equal to 1. So I have a to the first, and that's going to equal 3 times 2 to the 1 minus 1 power. Well, 1 minus 1 is 0, and 2 to the 0 power is 1, so 3 times 1 would equal 3. Next, if I want the second term in my sequence, I have 3 times 2, and this time the second term in my sequence, I'm going to use 2 for my n because it is the number 2 term. So when I finish calculating, I have 2 minus 1 as my exponent, which is 1. 2 to the first power is 2 times 3 would be 6. I want the third term in my sequence. So I have 3 times 2 to the 3 minus 1 power. That equals 3 times 2 squared. 2 to the second power is 4. 4 times 3 is 12. Lastly, a sub 4, the fourth term in my sequence. 3 times 2, the number of sequence term I'm on is 4, and then minus 1. 4 minus 1 is 3. 2 to the third power, 2 times 2 times 2 is 8. And 3 times 8 would be 24. So the first 4 terms in my sequence are 3, 6, 12, and 24. In the next example, I have 256 times 1/2 to the n minus 1 power. So if I want my first term, I take 256 times 1/2 to the 1 minus 1 power, because my first term is 1. That gives me 256 times 1/2 to the 0 power. Remember, any number to the 0 power is 1, and 1 times 256 would be 256. In the next example, I want to find my second term. So that's going to be 256 times 1/2 to the 2 minus 1 power, because it is my second term. That gives me 256 times 1/2 to the first power. 1/2 to the first power is 1/2, so half of 256 is 128. As my third term, I take 256, and that's going to be times 1/2 to the 3 minus 1 power to find my third term. 256 times 1/2 to the second power. 1/2 to the second power is 1/4, and 1/4 times 256 is 64. A to the 4th, which is my fourth term. So I have 256, 1/2, this time to the 4 minus 1 power because I'm looking for my fourth term. So that's going to be 256 times 1/2 to the third power. 1/2 to the third power is going to be 1/8, and I simply take 256 times 1/8 or 256 divided by 8, and I get 32. Now notice we worked all of these out, but there has to be a way to come up with a pattern for this. So for my first four terms, I have 3, 6, 12, 24. It looks like I'm multiplying by 2 each time. Where would I see that in the formula? Looking at my second sequence, I have 256, 128, 64, 32. Looks like I'm dividing by 2 each time. In this case, where would that dividing by 2, or in other words, multiplying by 1/2, be located? How would you write an explicit rule for a geometric sequence? Well, first of all, we want to look for the common rate. What are we multiplying by each time in order to get the next term in our sequence? I also need to know my a sub 1, which is my first term, and I need to know what term in the sequence I'm talking about. So here's the formula. A to sub n means what term am I looking for? I simply take my first term, I multiply it by the rate, which is to the power of n minus 1. So let's take a look at this example. First of all, I want to figure out what is my rate, or my common multiple. How am I getting from 7 to 21? I'm multiplying by 3 each time as I go into my consecutive terms of my sequence. So my rate is 3. I'm multiplying by 3. My a sub 1, which means the first term in my sequence, is 7. So to write the rule, we have a sub n, or whatever term I'm looking for, is my first term 7 times the rate, which is 3, to the n minus 1 power. In the second example, to get from 15 to negative 5, I'm actually dividing by negative 3. But remember, we're looking for a constant multiple. So instead of dividing by 3, I'm actually going to multiply by 1/3. And in order to get the correct sign, it has to be a negative 1/3. Again, multiplying by negative 1/3 would give me 5/3. So my rate is equal to negative 1/3, and my first term is 15. So my a sub n, the formula to calculate a term in my sequence, I start with my first term, a sub 1, which is 15. I'm going to multiply that times negative 1/3 to the n minus 1 power. The reason we do the n minus 1 power is because when you take your first term and put in a 1, 1 minus 1 is 0. Any number to the 0 power is 1. So your first term times 1 will actually give you your first term, which is 7 in that particular case. Let's take a look at some examples of writing the explicit rule for the nth term of the geometric sequence. In order to write the rule, what we do is we have our a sub n, and that is going to be our first term, negative 6, and the reason I put it in parentheses is so the negative stays attached to the 6. I'm going to multiply that by the rate, which is 6, and that's going to be to the n minus 1 power. In our next example, to write the rule, we have a sub n, meaning any term in the sequence I'm looking for. I take my first term, which is 5, and I'm going to multiply that by the rate, which is 4, to the n minus 1 power. And I should be able to calculate any term in the sequence that I'm looking for. Let's do the next one. So we have the explicit rule for the nth term. Well, 6 is not my first term. I want to get to my first term. Well, in order to do so, I want to multiply by 1/3. 6 times 1/3 is 2, so my a sub 1 is going to be the number 2. To write the rule, I have a sub n, and that equals my first term, which is 2. I'm going to multiply that by the rate, which is 1/3, to the n minus 1 power, and that rule will give me any term in my sequence that I am looking for. So, to review, remember a geometric sequence has a constant multiple called a rate. To write a rule, which is the explicit rule, we start with our a to the n, and that equals a to the sub 1, which is our first term, times the constant rate r to the n minus 1 power. Please remember to complete the reflection.